So in question number 7, we are given that y is equal to e to the power of sine inverse x. In part A, we are supposed to show the equation. In part A, okay, we know this is a Maclaurin's question, okay, but part A that is given to us, it is more of like a differentiation technique question. And I think it is good for us to not just simply work on differentiation as a technique. We should also work on differentiation technique, but at the same time, we also want to make sure that we are able to improvise and strategize, like how we have discussed for the few parts that we have experienced in the previous questions. So what I'm going to do is, for what that is given to me here, I don't think it is so, it is an equation that is friendly enough for us to differentiate it directly. So with a bit of thoughts again, and with me willing to carry out a bit of my own improvisation, to initiate my own improvisation, what I think I'm going to try to do is to ln both sides, which will give me a ln y is equal to sine inverse x, because I do think that this version is easier for me to differentiate. So from here, if I were to differentiate the left hand side with respect to x, I'm going to be getting a 1 over y dy dx. This is going to be equal to 1 over square root of 1 minus x squared. And if you have to look at what you are supposed to be showing, I don't think I will want to leave this square root of 1 minus x squared in the denominator. Okay, because this is going to get sort of like complicated. So what I'm going to do is I'm going to just cross multiply. Okay, I'm going to multiply this across and y. I'll multiply across to the other side. So we have a square root of 1 minus x squared dy dx. This is equal to y. Again, I'm initiating some improvisation here, okay, which the question didn't tell me so, but we are trying to come up with a plan, a strategy that hopefully will work in terms of getting a more efficient set of solutions. So let's see whether our plan really works, okay? It works based on the fact that we are going to be deriving what we are supposed to be showing faster and more efficiently. So from here, let's try, okay? Let's try to differentiate it one more time. And let's see whether we will be able to get the equation that the question is asking me to show. So on the left hand side, I'm going to apply the product rule. So square root of 1 minus x squared. I'm going to leave it as it is. Differentiating this is going to be d squared y dx squared. Then differentiating this now, it is going to be half 1 minus x squared to the power of minus half minus 2x. Then dy dx is equal to, this will be dy dx. And let's simplify this a bit first before we decide what to do next. So simplifying this, we'll have a minus x over square root of 1 minus x squared. Then dy dx, this is also going to be equal to dy dx. And now, if I were to try to multiply throughout by square root of 1 minus x squared, this will become the same coefficient as the coefficient of d squared y dx squared. So it seems like the strategy is still working. So let's continue. So multiplying this through this equation throughout by this square root of 1 minus x squared will give me a 1 minus x squared, then d squared y dx squared minus x dy dx is equal to square root of 1 minus x squared dy dx. So we have achieved this because this is what the question wants me to show. And we actually have this also, this x dy dx, which is going to be obtained the moment when I bring this over to the right hand side. So let me do that. So we have a 1 minus x squared, then d squared y dx squared. Bringing this over to the right hand side, it is x dy dx plus this over here. And according to what the question is asking for, this over here is supposed to be changed to y. Is it possible? Yes, it is possible, because if I were to just trace back to what we have, it is from here, where y is equal to square root of 1 minus x squared. And we have a square root of 1 minus x squared, so based on this is now going to be converted to y, and this is exactly according to what the question wants us to show. So I guess our strategy works well. Let's move on to B. B, we are now supposed to be finding the first 4 terms of the Maclaurin's expansion of e to the power sine inverse x. So we are going to be making use of the formula for Maclaurin's. We already have y, we already have an equation for dy dx, and we also now have an equation for d squared y dx squared. We need one more in order for us to derive the first 4 terms of the Maclaurin's expansion. At least one more, which is an equation for d cubed y dx cubed. So let's try to differentiate this. Applying product rule to this, we'll have a 1 minus x squared d cubed y dx cubed, then plus minus 2x multiplied by d squared y dx squared is equal to, again applying the product rule to this, this will be x d squared y dx squared plus 1 time of dy dx plus differentiating y with respect to x, it is still going to be equal to dy dx. Simplifying this, 1 minus x squared d cubed y dx cubed. This, I'm going to bring it over to the right hand side to combine with this, which will give me a 3x d squared y dx squared. Then this, it will be 2 times of dy dx. Okay, now we are ready to come up with a part of the coefficients of the Maclaurin series expansion for the first 4 terms. So the coefficients, part of them will be obtained from letting x be equal to 0 and getting the value for y. Y is equal to e to the power of sine inverse 0. Sine inverse 0 is 0, so e to the power of 0, this is equal to 1. And I'm going to find dy dx. dy dx will be y divided by this. So it will be y, which is 1, divided by square root of 1 minus x, which is 0 square. So dy dx is also going to be equal to 1. d square y dx square. So d square y dx square. This is going to be equal to x, which is 0. Nice. So this plus y is equal to 1. Divided by this, which is going to be 1 minus 0 squared. This is equal to 1. Let's find the last part of the coefficient, d cubed y dx cubed. So this is going to be equal to, again, 0. Nice. Plus 2 times of dy dx, which is 1. Divided by 1 minus 0 squared. So this is equal to 2. Now we know the Maclaurin's expanded form for e to the power of sine inverse x. It is going to be equal to f0, which is going to be equal to 1, plus f prime 0 x. So it's going to be 1 time of x. Then plus f prime prime 0, which is going to be 1, over 2 factorial of x squared, plus f prime 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 0. So this divided by 3 factorial of x to the power 3 and so on. Since we have already gotten the first 4 terms, I don't really need to write down the rest of the terms here. This will give me a 1 plus x plus 1 over 2x squared plus 1 over 3x to the power 3 all the way till infinity.